Hello viewers, in today's class we are going to solve one important definite integral involving absolute value function, right? So here we have to integrate mod of sine 2 pi x from 0 to 1, right? So let us start. Let us first call this integral as I, right? And here we see that the value of x, it varies from 0 to 1, right? Now here uh, our integrand is an absolute value function, right? So here to evaluate this definite integral we have to make use of different concepts, right? So the first concept is to find out the critical points of this function, and here the critical points would be obtained by putting sine 2 pi x equal to 0, right? So the critical points are obtained by putting this function equal to 0, right? Now this is a trigonometric equation, right? And we know that if we have a trigonometric equation of this type, sine theta is equal to 0, then the solution of this equation is given by theta is equal to n pi, right? Where n is an integer, right? So here for theta we have 2 pi x, right? So the solution of this trigonometric equation is the sine, here we can write 2 pi x is equal to n pi, right? Where n is an integer. Now here x is equal to n pi over 2 pi, and we have x is equal to n over 2, right? Pi and pi get cancelled, so we have x is equal to n over 2, where n is an integer, that is 0 plus minus 1 plus minus 2 and so on, right? Now if we take n is equal to 0, right, then the value of x is 0 over 2, that is 0, and here we have the lower limit of this integral as 0, right? Okay, now if we take n is equal to 1, then we have x is equal to 1 over 2, that is half, right? And this is 0.5, and we see that half lies between 0 and 1, right? And similarly, if we take n is equal to minus 1 or minus 2, then we get different values of x, but we are interested only in the value of x which is obtained by putting n is equal to 1, because it gives x is equal to half, and half lies between 0 and 1. Here we have 0 and here we have 1, and half lies between 0 and 1, right? So this is the point where we have to break this integral I into a sum of two integrals, right? That is I is equal to I1 plus I2, right? So I1 is from 0 to half, and I2 is from half to 1, right? Now we have to apply the concept of absolute value function, or the definition of absolute value function to decide the sign of this mod of sine 2 pi x, right? So now here I1 is from 0 to half, and we have mod of sine 2 pi x dx, and here we have half to 1 mod of sine 2 pi x dx, right? Okay, so now let us use the definition of absolute value function. Now we know that mod of y is equal to positive y whenever y is greater than or equal to 0, and minus y whenever y is less than 0, right? And here we'll take y is equal to sine 2 pi x, right? Now before deciding the sign of this function, let us take the values of x which lies between these intervals, that is from 0 to half and from half to 1, right? So let us first take this integral where x varies from 0 to half, right? So when x varies from 0 to half, then if we multiply this inequality by 2 pi, right? Because here we have to find this angle, that is 2 pi x, right? So when x lies between 0 and half, then if we multiply this entire inequality by 2 pi, then we get 0, and here we get 2 pi x, and here we get 2 and 2 get cancelled, so we have pi, right? So here this angle 2 pi x, which is if we take 2 pi x as theta, then we see that theta lies between 0 and pi, and it shows that theta can be anywhere between first quadrant and the second quadrant, right? So here we have 0, and here we have pi over 2, here we have pi, here we have 3 pi by 2, and then we have 2 pi, right? So when theta or 2 pi x lies between 0 and pi, it means we are either in the first quadrant or in the second quadrant, and when theta is in first or second quadrant, then the value of sine theta is positive, right? Because this is an important result from trigonometry, right? So when theta lies between first quadrant or in the second quadrant, then the value of sine theta is always positive, and here we have taken theta is equal to 2 pi x, right? So sine 2 pi x is positive whenever 2 pi x lies between 0 and pi, right? Now let us take this integral, right? So here we see that x lies between half and 1, right? Now again, if we multiply this entire inequality by 2 pi, then 2 and 2 get cancelled, and here we have pi, and here we have 2 pi x, and here we have 2 pi, right? And 2 pi x, we are taking 2 pi x as theta, so theta lies between pi and 2 pi. It means now the angle 2 pi x or theta, it lies between either in the third quadrant or in the fourth quadrant, right? And from trigonometry we know that sine theta is a negative quantity whenever this angle theta lies between pi and 2 pi, or in the third quadrant or in the fourth quadrant, right? So sine 2 pi x is a negative number whenever 2 pi x it lies either in the third quadrant or in the fourth quadrant, right? So now let us apply this definition to this function, right? So mod of sine 2 pi x is equal to positive sine 2 pi x whenever x lies 2 pi x lies between 0 and pi, or we can say x lies between 0 and half, right? And mod of sine 2 pi x is negative sine 2 pi x whenever x lies between half and 1, right? So this is an important concept in trigonometry, right? To decide the sign of trigonometric functions in different quadrants, right? So sine theta or the sine function is positive in the first and second quadrant, and sine function is negative in the third and fourth quadrant, right? So that's why we have written this statement, right? So now from this equation we can write I as integral 0 to half. So when x lies between 0 to half, then mod of sine 2 pi x is positive sine 2 pi x, right? And the second integral is from half to 1, and when x lies between half and 1, then mod of sine 2 pi x is negative sine 2 pi x, because x lies between half and 1, right? So now this is the situation, and now we have two simple integrals here, and we know that the integral of sine theta is minus cos theta, right? So here theta is 2 pi x, right? So the integral of sine 2 pi x is 1 over 2 pi minus 1 over 2 pi and cos 2 pi x, right? And the limits are from 0 to half, right? And similarly here we take this negative sign outside the integral, and the integral of sine 2 pi x is minus 1 over 2 pi, and we have cos of 2 pi x, and the limits are from half to 1, right? Okay, so now we can further simplify it. So we have minus 1 over 2 pi, we can take it outside, and we have cos 2 pi x, and limits are from 0 to half, and here minus and minus becomes plus, so we have plus 1 over 2 pi, and here we have cos of 2 pi x, and the limits are from half to 1, right? So now we can simply substitute the limits. So when we take x is equal to half, so we have 2 pi over 2, that is simply pi, and when x is 0, here we have simply cos of 0, right? And here we have 1 over 2 pi, and when x is 1, then here we have cos of simply 2 pi minus, and when x is half, here we have cos of pi, right? And from trigonometry we know that the value of cos pi is minus 1, and the value of cos 2 pi is plus 1, right? So substituting these values over here, cos of 0 is also 1, right? So we have minus 1 over 2 pi. Here we have minus 1, here we have 1, so minus 1 plus 1 over 2 pi. Here we have 1, and here we have minus 1, right? So this is minus 1 over 2 pi, this is minus 2 plus 1 over 2 pi, and here minus minus plus, so we have 1 plus 1, 2, right? And minus and minus, when we multiply these two we get plus, and 2 and 2 get cancelled, we have 1 over pi. Here 2 and 2 get cancelled, and we have 1 over pi, right? And 1 over pi plus 1 over pi is 1 plus 1 over pi, that is 2 over pi, right? So the value of this integral, that is 0 to 1 mod of sine 2 pi x dx, is equal to 2 over pi, right? So viewers, this is how we solve this important problem with the help of different concepts used in trigonometry, right?